Hello and welcome to Jijo Speaks. In this video, we are going to quant again and we're going to deal with the question which is numbers. In quant, in CAT, you've got arithmetic, algebra, geometry, modern maths, and numbers. A lot of people say that it's just that numbers is not really important. So I want to address that particular question. Is that the case? So we will look at CAT 2022 questions, a few of them, and try and answer this simple question that should we ignore numbers? Should we just focus on arithmetic, algebra, and maybe a little bit of geometry because CAT just does not ask any questions on numbers? That is what we are exploring. So let's go to the screen. Now, if I look at CAT, right, you see there is arithmetic, sir, 8 question, 9 questions, slot 1, slot 2, slot 3. Algebra is 7 questions. Now, if I want to hit the 99 percentile, I have to get 11 questions correct. If I want to hit the 97 percentile, I'm looking at what? 8 to 9 questions net correct. So, which means that if I am very good in algebra, arithmetic, so example, and a little bit of algebra, my life is fine. Why should I even bother about this fellow called numbers when it is given in all the analysis that I've seen? The number of questions from numbers. What are these numbers essentially? Factors, multiples, Then we'll have things like what? Remainders, divisibility. These concepts now. It is just one question. Why should I sit and waste my time? Is actually the question. So let's explore that. And that's what we're going to do. Are you ready? So let's start. Now, I have a question on the screen. Now, this particular question is not a CAT question, just a question. You can pause the video and try it and solve it yourself. Okay? So, when I see something like this, wherein I see y square equal to 10x plus 1, I'm thinking it's algebra. Or probably I'll have to use certain concepts of algebra to navigate this particular question and solve this. But the question is telling us how many solutions exist for the equation y square equal to 10x plus 1, where y is an integer and x is a prime number. So these are talking about number or the concept that exists in number system. What do we do? What do we do? You're talking about prime numbers. If its concept exists in number system, should I think in terms of factors, multiples, and those things, divisibility and those things, or should I just look at this from algebra's point of view? Now, if I look at this particular equation, if I write it down, y square equal to 101x plus 1. Okay. Now, if I want to take this side, I'll probably write this as y square minus 1 equal to 101 times x. Now, y square minus 1, I can write it as y minus 1 times y plus 1 equal to 101 times x. That is where I could reach. But ever notice something? If I for the time being forget about algebra and get to the realm of numbers, I can actually see that this particular number 101, this particular number is a prime number. And it's also given that x is also a prime number. Oh, okay. Wait a minute. I know something. If let's say I have to write something into two numbers, a times b, and let's say that is equal to 15. Or okay, what is the only way that I can cut 15? There are two ways actually to do it. One way to do it is to type at 15 times 1. Other way to write it is 3 times 5 or 5 times 3, where 3 is a prime number and 5 is a prime number. The point that I'm telling you is the question is simply asking, okay, this 3 times 5, how do I write this? What value will go here and what value can happen? There are only two possibilities. That is number one, which means one possibility is one of these number is 3 and other number has to be equal to 5. Now, I think what is y minus 1 and y plus 1? Y is an integer. If I think about a number line, and I've got all these numbers in the number line, if let's say y is here, y minus 1 is this number, and y plus 1 is that number. So this means that this number is 2 more than this number. So I cannot, therefore, this one does not work. I cannot put one of the values one here. That does not work. So what is the only way I can deal with this? The only way I can deal with this is say that since I cannot break this any further, these two values, I cannot break it any further. The only way to write is, so one of these values should be 101, other value has to be equal to x. There are two possibilities. I can think about, let's say, possibility number one, where y minus 1 is 101 and y plus 1 is x. Possibility number two is y minus 1 is x and y plus 1 is 101. Those are the only two possibilities that exist. Now, if, for example, if I look at the first one, if y minus 1 is 101, y plus 1 will be 2 more than that, which is 103. Now, here I can say that x takes the value 103 and it's given that x is a prime number. So this is a prime number. So this kind of thing satisfies. So one value that is possible, that x equal to 103. We're looking at a number of solutions. What about the second case? If y plus 1 is 101, if it is true that y plus 1 is 101, therefore y minus 1 will be 2 less than that. That will be 99. So here x is going to take the value which is 99, but we are treating x as a prime number here. So 99 is not a prime number. This is not a solution. You have only one solution, which is this one. Answer is 1. Now I'm going to ask you a question. The question is very simple. What will you treat this sort of question as? Would you treat this question as algebra question? Would you treat this question as number question? The point is, when there are these algebra mentioned here, 8, 8, 8, 8, and 7, and numbers is mentioned separately, this particular table is not telling you one reality. That reality is that there could be a question which involves both algebra and numbers. You know what those equations are called? That is a name for the equation. That is gentleman called Diophantus. Diophantus from AD 300s, okay, Greek sort of mathematician. There are equations that are called Diophantine equations. Diophantine equations are those polynomials where you have solutions are integers. The moment you have questions with integer solution, they're going to behave in a very different fashion. What are integers? Your numbers that are very discrete, it keeps jumping. So if it is, you're looking at a few things. Number one, you're looking at concepts like factors, multiples. Another thing about integers is that they behave in a particular fashion. There could be some patterns. So if I look at CAT questions, and let's look at a few of them. Let's look at CAT 2022. I've taken 3 questions from the slot 1 and about a couple of questions from slot 2 last year, just to illustrate this particular point. Let's, for example, look at this question. This is CAT 2022 slot 1 question. And when you just look at this question, you see variables x, y plus y, z equal to 19. You see variables y, z plus x to 51. And you are thinking, this question is algebra. That is likely where you're going to slot this. But I also see one more thing. These are natural numbers. X, y, and z are natural numbers. Wait a minute. I can make sense of this number, 19. 19, I know, is a prime number. Right? I also can see a y that is common. So if I take y out, I can break this down into something times something equals to 19. Wait a minute. But I cannot break 19 any further. So the only way to think is that has been 19 times 1. So I also can see z common here. I can therefore take z out and break this into something a times b, and that is equal to 51. Gives a couple of possibilities, 51 times 1, and 51 can be broken down into 17 times 3. So I'm no longer thinking algebra because I saw natural numbers. I'm thinking numbers. So here I've got xy plus yz equals to 19, and yz plus xz equals to 51. I can take y common here. Y times x plus z equals to 19. And what is the only way I can break? You know that y has to be a natural number, x is a natural number, z is a natural number. So x plus z is also a natural number. I am asked to find out two numbers and multiply these two numbers and tell me what is a possibility. There is only one possibility. One of the number has to be 19, other number has to be 1. Which of these number has to be 1? X plus z cannot be equal to 1 because both x and z are natural numbers. The smallest natural number in itself is 1. So the only possibility is that y has to be equal to 1 and x plus z has to be equal to 19. Wonderful. What about this side? If I take z out, x plus y equals to 51. Now we already know that y is equal to 1. So I can say that z times x plus 1 equal to 51. How can I break this? I can break this by saying that it has to be, let's say, 17 times 3. Oh, that's wonderful, which gives me two possibilities. Possibility number 1 says that z is 17 and this x plus 1 can be equal to 3. Possibility number 2 is the other way around. Z is 3 and x plus 1 is 17. I am not considering 51 times 1 because it doesn't work. 51 is suddenly becomes a huge number. If x plus 1 is 51, x becomes 50, it's over. The story cannot happen. Right? So this is anyway out. That's why I'm not considering it. From here, I can get values. I can get the value of x to be equal to, if it is 3, but x plus 1 is equal to 3, x has to be equal to 2. Y, anyway, we found out is equal to 1, which is here, right? And z would be equal to 17. And this also kind of works because then x plus z has to be equal to 19. 2 plus 17 equals to 19, and that works, right? And the second possibility, we have got x plus 1 equal to 17, which means x has to be equal to 16. Y anyway, we found it equal to 1, and z has to be equal to 3. This also works. X plus z has to be 19. 16 plus 3 is 19. So you've got two cases. The question is asking to find out what is the minimum possible value of x plus z. Will be one of these two. X, y, z, sorry. So the value of x, y, z here is 2 times 1 times 17, which will be equal to 34. The value of x, y, z here is 16 times 1 times 3, it will be equal to 48. Which is the smallest value? That smallest value is 34. The answer choice is 34. To answer this question, did you think algebra or did you think numbers? I need to know a little bit of algebra to get me here. So that algebra we know. Okay. All right. Let's, for example, look one more question. This is CAT 2022 slot number 1. Again, the same thing. I notice that I've got some crazy looking equation. I've got another equation, two equation, two variables. Oh, I can think algebra. Oh, I can do something. I can find out. I can substitute. I can do something. I'm thinking algebra. Then I'm looking at the question and going, wait a minute. I can see natural numbers. So why am I thinking algebra? Why can't I think numbers? Why can't I think concept of numbers? Concept of numbers are factors, multiples, patterns, and things like that. Factors, multiples. Why can't I think that? All right, let's think in that particular fashion instead of algebra. I'll do a little bit of algebra to get there because what I found out is that I can see A common. So I can take A out. Something will be left. That'll be equal to 14. Okay, that can return as 14 times 1, 7 times 2. All that is possibility. Here again, I can take B out, which means I can write the product of two numbers. That'll be equal to 28. Oh, that could be 7 times 4, 14 times 2, 28 times 1. Oh, there are very few cases. And I probably will be able to compare these two things and ease my problem. Let's go toward this side and look at this number from a question from perspective of numbers, concept of numbers. So let's start writing those two values there. We have got a squared plus ab plus a equals to 14 and b squared plus ab plus b equal to 28. I also notice very symmetrical. The point that I'm saying is if I take a out, from here we'll get a. What is left is b. And what is left is 1. That should be equal to 14. Now, if I take b out, what is left is b, what is left is a plus 1. That will be equal to 28. Immediately notice that a plus b plus 1 Is b plus a plus 1? These two are same. Oh, these two are same. Come on, these two are same. Oh, okay. So let's forget algebra. Let's think numbers. What is common between 14 and 28? Two things can be common. It could be 7, it could be 14. Wait a minute. Does 14 work? Does 14 work? Can I think about case number 1, where simply say this is 14 times 1, it will be equal to 1. And this is 14, and therefore this particular thing will also be 14 times 2. Does that work? Oh, does it work? Which means if A has to be equal to 1, B equal to 2, and A plus B plus 1 cannot be 14. So this is not working. Okay, let's discard this case. What is left? What is another common fellow? Can I think 7? 7, okay, I can say this can be 7. This can be 7. This seems to work. All right, 7 times 2 equals to 14. 7 times 4 equals to 28. Would this work? All right, A equal to 2, B equal to 4. So which means A plus B plus 1 will be 2 plus 4 plus 1, which will 6 plus 1, which will be equal to 7. This works. I got A equal to 2, B equal to 4. All I need to find out is 2A plus B. So I've got 2 times A is 2 plus B is 4. 4 plus 4 gives me 8. That will be answer to question number 2. Wait a minute. Wait a minute. Where will I slot this question? Will I slot this question as a number question? Will I slot this question as an algebra question? This contains both. Why did I not have to break my head trying to use some logic to write this equation together? A square plus AB plus 1 is B. I can just think about numbers. Wait. All right. And this particular question was slotted as a number question. Okay. This was slotted as a number question. Great. No problem. Okay. I think what is happening is that I look at these things, 3 raised to k plus 4 to the power of k, 5 to the power of k. 4 to the power of k. What is that? No, wait a minute. Numbers are cute. Okay, let's see. Let A be the largest positive integer that divides all the number of the form. So HCF, highest common factor, right? Instead of writing A is HCF, highest common factor of all the numbers of that particular form. And B is the largest positive integer that divides all the number of the form. Largest positive integer that divides everything would be HCF, highest common factor. Okay, fair enough. Okay, let's write this down. A is the HCF of what? This is number 3 to the power of k plus 4 to the power of k plus 5 to the power of k. And B is the highest common factor of this number 4 to the power of k times 3 times 4 to the power of k. Oops, let me write it better. Plus 4 times 4 to the power of k plus 2. In fact, between these two, the second one is better because I can see 4 to the power of k, I can see a 4 to the power of k, and what is 4 to the power of k plus 2? 4 to the power of k plus 2 is 4 to the power of k times 4 to the power of 2. The 4 to the power of k is common. Wait a minute, I can take 4 to the power of k out. What is remains? Okay, here I'll just 1, I'll get a 3 here, plus I'll get a 4 square, which will be 16. 16 plus 3 plus 1 is 20. This is 4 to the power of k times 20, which is what are the numbers that we're looking at? 4 to the power of 1 times 20, 4 to the power of 2 times 20, 4 to the power of 3 times 20. बताओ इसका HCF क्या है? What is the highest common factor? It's very simple. The highest common factor, every number here is 4 and every number has got a 20. The highest common factor here has to be 4 times 20, which will be equal to 80. I found that out. All right, now let's go to A. This is looking very crazy, so I can't take anything common. What do I start thinking? Okay, wait a minute. All I have to figure out is the highest common factor. It has to be a factor of every single number. So why don't I try for the first 2 to 3 numbers and check out what happens? I can put k equal to 1. So I have to just look at, okay, I can find that out. Let's do some working with respect to the first fellow. I can start thinking, let's say for A, is the 3 to the power of k plus 4 to the power of k plus 5 to the power of k. Let's say what if k equal to 1? That is 3 to the power of 1, which is 3, plus 4 to the power of 1 is 4, plus 5 to the power of 1 is 5. That is what? 9, 12. Let's put k equal to 2. That will be 3 square, which will be equal to 9. 4 square, it will be equal to 16. 5 square will be equal to 25. 16 plus 9 is 25. 20 plus 25 is 50. Oh, and then I don't want to move forward because what I notice immediately is that for a highest common factor to exist, the highest common factor between 12 and 50 is only 2, at least for this part. So when k equal to 1 and k equal to 2, I have to check it has to be true for every single value of k. Because what I found out is that the only thing that is common here is 2. So all I have to check, can 2 divide everything else? The only possible fellow is 2. Can do 2 divide everything else? How am I thinking? What is a number divisible by 2 called? What is it called? Is it called anything? I think I studied it. I think I studied in school. I think it's called an even number. So all I have to check is it even for any value of k? All right, I know some concepts. 3 is an odd number. Odd number raised to anything. This is going to be odd. 4 is an even number. Even number raised to anything. That's going to be an even. 5 is an odd number. Odd number raised to anything. That's going to be odd. Essentially, what am I doing? I'm adding an odd number plus an even number plus another odd number. This I know odd plus odd will give me even, and even plus even will give me even. This number is always going to be even. So which means every single value of k would be divisible by 2 and nothing else. Everything. So a takes the value 2, b takes the value 80. I need to find out a plus b. A plus b, 80 plus 2 is equal to 82. Just one? No. 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 The reason why you look like this is because you got a question which has got a which is a Diophantine equation, which is asking you to find out natural integer solution, and which requires a little bit of algebra, concept of numbers together. And if I have to slot it like this, then where do I slot? If there is a question which is a combination of arithmetic and algebra, the question has got geometry and arithmetic together, or geometry and concept of numbers, which is there, no? You've got a lot of these where you have got triangles with integer values, but I kind of slot it somewhere. So sometimes this can be actually misleading. Let's look at CAT 2022 slot 2 as well. A few questions, one more idea. So one thing that you see is that these kind of questions, when I see I have to look at factors multiple, there's another thing that you should also look at, which is this whole idea of patterns. See, let's go to the question. Let me explain. Okay, this is a CAT 2022 slot 1 question. For any natural number n, okay, great. Suppose the sum of the first n terms of an arithmetic progression. What is an arithmetic progression? Arithmetic progression is, in this case, a natural number. The term 1, term 2, term 3, term 4, and so on and so forth. So it's the first number plus a common difference, right? So can I simply say that arithmetic progression is nothing but a sequence of numbers that behaves? I'm using the word behaves. It's behaving. Okay. Is it not? Let's look at another sequence of numbers, that 1, 4, 9, 16, 25. It's a sequence of number that behaves in a constrained manner. Think about, for example, cyclicity. You've learned cyclicity as a sort of different concepts, right? What is cyclicity? Let's say the last digit of 7 to the power of n. 7 raised to 1 ends with a 7. 7 square ends with a 9. 7 cube ends with a 3. 7 raised to 4 ends with a 1. 7 raised to 5 ends with a 7. 9, 3, and 1. There's also a sequence of number that behaves. It's a repeating sequence, but a sequence that behaves. So I'm simply thinking, instead of calling it a lot of the sequences, sequences of natural numbers will behave. And I need to understand their behavior. I know the behavior of arithmetic progression, which behaves in this particular fashion. All right, great. So now it says, the nth term of the progression is divisible by 9. then the smallest possible value of n is. Okay, first of all, the answer choice is very small. That doesn't tell me. I've got arithmetic progression t1, t2, t3, term 4, term 5, term 6, term 7, term 8, and term 9. Okay, and because the maximum answer choice is only going till 9, which is the smallest one that is reduced by 9, which means if I take values, I find out the first number that is going to be reduced by 9, I'm going to pick it. Great. If I have to figure out the sequence, all I need to know is the first number plus the common difference. Or let's say the first number and the second number. I can answer it because if I know the first number and the common difference, I can generate. Or if I know the first number and the second number, then I can figure out the common difference. I can generate everything else. So all I'm thinking in this particular question is, since only going till 9, let's just figure out what the first number and second number is. But what is given is sum of first n terms. All right. So n sum of first n terms is given as n plus 2n squared. So what is sum of one term? Will be just t1. What is sum of two terms? t1 plus t2. Wait a minute. And from here, if I subtract this to this, I can find out t2 as well. This is awesome. So what is t1? I'll substitute n equal to 1. 1 plus 2 equal to 3. I got the first number, which is equal to 3. All I need to get is the second number. Okay, what is n equal to 2? S2 will be t1 plus t2, sum of the first two numbers of the sequence. 2 plus 2 times 4, 10. Right? Yeah. 2 times 2 square. The second value equals to 10. The 10. The sum is 10. I already know t1 equal to 3. So t2 will be equal to 7. I know that this is a sequence that adding 4. All right. I have to find out what I find out. I have to find out the first fellow that gives me a value which is divisible by 9. This is adding 4. I can add 4. I know this. 11 plus 4 is 15. 19. 23. So far 27. 27 is the first number that is divisible by 9. Answer choice is 2. Okay. Now, of course, you're asking this question, what if this would have been a huge number? Then I'll use the same concept, right? And I will take a general case to figure out the sequence. Any term would be, let's say, the n term minus the previous one, right? So Tn, if I want to figure out the second term, I have to take the sum of the second term minus the sum of the previous term, n minus 1. And then you can substitute the value of here and you eventually figure out and you'll get something. But the point that I want to tell you with this particular question is a sequence of number that behaves. In general, that behaves. If I understand their behavior, I can understand the sequence. Now you will see this question. And you will think that this question and this question is very different. Sir, this is from arithmetic progression, this is from function. Suppose all integers of x are two functions f and g such that, okay, f of x plus f of x minus 1 minus 1 equal to 0. All right, okay. G of x equal to x squared. When I look at g of x equal to x squared, what does that mean? If I keep putting the value of x, if x equal to 1, I'll get the value 1. X equal to 2, 2 square is 4, 3 square is 9, 4 square is 16. This simply represents a sequence of numbers that behaves, and I can understand the behavior of the number, of the sequence. That's it. Okay, and the next one that is given as the second one that is given is f of x square minus x equal to 5. Okay, now we have to deal with f of x. It is fine. It's fine. It's okay. So far, so good. Let's carry on. We'll have to figure out, we need to understand the behavior of f of x. G of x behavior is very easy to figure out. But how is this function f of x doing? What is the number's behavior? Because I understand we are dealing with integers and integers behave. I just need to understand their behavior or pattern, whatever I call it. Then what we need to find out in the sum of these things, what I need to find out, what I have to find out f of g of 5 plus g of f of 5. Okay, wait a minute. Okay, all right. G of x equal to x squared. So g of 5 will be simply 5 squared, which is 25. So this entire term here is This is simply 25. So I can write this as f of 25 plus, okay, all right. I see that g of x equal to x squared, right? So g of whatever is inside is square of that. So here I'll need to find out f of 5 squared. Now, for me to figure out, I need to understand what will be the fifth value of that sequence, which is behaving, and what will be the 25th value. Okay, now I need to understand how the sequence behave. Okay, let's start. What this is telling me is that this is actually giving me some values. Okay, so imagine let's put x equal to 0. 0 can be the first term, it doesn't matter. If x equal to 0, f of 0 will be equal to 5. I don't know what is f of 1, and the sequence is moving f of 2, f of 3, f of 4. This is like the first term, second term, third term, and so on and so forth. This sequence behave. Now maybe if I put x equal to 1, f of 0 equal to 5, so that's the same thing. Okay, if I put x equal to 2, I can see 4 square is 2 square. Sorry, 2 square is 4. 4 minus 2 is 2. I can also see that f of 2 equal to 5. So I can probably get some values, right? But there are a lot of the missing values. I need to get to f of 5. Is there anything? What is this information telling me? Wait a minute. Wait a minute. This is telling me how the sequence behave. That's all it's telling me. Why? Because if I take f of x here equals and puts everything that side, 1 minus f of x minus 1. How do I interpret this? Wait a minute. If I want to find out f of 1, all that means is 1 minus f of 0. Wait a minute. Wait a minute. If I want to find out f of 2, that means 1 minus f of 1. If I want to find out f of 3, that is 1 minus f of 2. That simply means for me to find this value here, all I have to do is subtract 1 minus this value. That's it. What is 1 minus 5? Minus 4, negative 4. Okay, this makes sense. Negative 4. If I have to find out this value, I'm saying I'm just checking whether this logic is correct. If you want to take this value, all I have to do is 1 minus the previous value. The previous value is negative 4. So 1 minus negative 4 will be again 5. Oh, what is going on? Okay, what I understood the behavior. What is F3? 1 minus the previous value, that is negative 4. What is F4? Oh, this is a repeating sequence. But I understand this. Oh, I have got f of 5 equals to negative 4. So for f of 5 square of that, it will be equal to 16. But I also notice a pattern. Whenever this inside fellow is a odd number, it is negative 4. 25 is an odd number, that will be negative 4. Negative 4 plus 16 equals to 12. That's it. While you're saying that this particular question and this particular question is very different, but what is common between this particular question is a sequence that behaves. Let me also, for example, talk about other sequences that behave. If you think about, for example, somebody wants to find out 2 raised to 2007 divided by, okay, let me write it this side. Okay, wait a minute. Remainder, when 2 raised to 2007 is divided by 9 or divided by 7, let's take divided by 7. Okay, so I think there are a lot of ways to solve it. You can convert this into kind of sequence, or I'm just going to take 2 raised to n divided by 7. Let me understand how the sequence behave, and understanding the behavior, let me try and find out what answer of this. That's how you solve. Right? So, okay, let's think what happens when 2 raised to 1 is divided by 7. 2 square is divided by 7. 2 cube is divided by 7. 2 raised to 4 is divided by 7. 2 raised to 5 is divided by 7. And so on and so forth. And then figure out where will 2 raised to 2007 exist. Understanding the sequence. 2 raised to 1 is 2. What is 2 divided by 7? Everybody knows. I think that I cannot do this. 2 divided by 7, remainder is 2. This value is going to be equal to 2. Again, 4 divided by 7. The remainder has to be 4. 8 divided by 7. Remainder has to be equal to 1. 2 raised to the 16 divided by 7. That is what? 14. Remainder is 2. Wait a minute. 32 divided by 7. What is 28? Remainder is 4. Wait a minute. Wait a minute. What's going on? What's going on? There is a sequence of numbers that behave. 3. Everywhere I can see when the power is a multiple of 3, the answer seems to be 1. I need to find out 2007. 2007 is a multiple of 3. Therefore, this is going to fall under 1. All these are one and the same numbers behaving. And we'll deal with one last question. This is probably a slaughters in numbers. And you saw this and went, my God, what is this? For some natural number n, assume that 15,000 factorial is divisible by n factorial ka factorial. The largest possible value of n. Okay, we understand what is 15,000 factorial. 15,000 factorial is nothing but there's 1 times 2 times 3 times 4 times 5 times so on and so forth. You keep multiplying till you reach the number 15,000. You cannot exactly find the value of this because you don't know. But what is this n factorial and the factorial of that? Nothing. If n equal to 2, that is 2 factorial ka factorial. What is 2 factorial? Which is 2. This value is 2. That will eventually come to 2 factorial. What if n equal to 3? That will be 3 factorials factorial. But I know 3 factorial is 6. This will be nothing but 6 factorial. So if the largest possible value of n is what you need to find out. If n equal to 4, what you were actually checking, what is 4 factorial? That is 24. Uska factorial. N equal to 5, what is 5 factorial? If you want to look at 5 factorial, that is 5 times 4 factorial. No, well, because 4 times 4, 3, 2, 1. 5 times that is 120. Uska factorial. 6 is 120 times 6, that is 720. Uska factorial. And 7 is 720 times 7, 3040 factorial. Now you have to look at the largest possible value of n, which divides this. Let me check the largest possible value at 3040. What does 3040 factorial divide this fellow? What is 3040 factorial? 1 times 2 times 3 times 4 times 5 up till 3040 and it stops. There is a 3040 somewhere here. Obviously, it's going to divide. And that's the largest. Everything divides. That is the largest. That's it. Okay. Now, by the way, 8 factorial doesn't work. Because what is 8 factorial? 8 factorial is 8 times 7 factorial, right? That is 8 factorial. So 7 factorial 3040. So 3040 times 8. This is 0. Let's do 32, 24. 24,300. So this is 24,320 factorial. This is not going to work. 15,000 factorial divided by 24,320 factorial. So it doesn't work. Well, that's it. So the point that I wanted to tell you is simply this. When you see this data, and I think somebody has to look at one question, which has got both numbers as well as algebra concepts, and you want to slot it somewhere. The most of the time it gets slotted here because there is no column that says numbers in algebra concept. And that is why you keep seeing the numbers are low. But I would recommend you to look at the recent past CAT question. Next time you see any algebra looking questions, and then there is this, you're treating natural numbers in the sense integers. That is when I'm calling as numbers at this point in time, integers, okay? Integers, numbers that behave, any integers, positive, negative, whatever. Then algebra is important. But then also thinking numbers, factors, multiples, patterns. I do hope that this made sense to you. And ladies and gentlemen, if there is, you want me to do any more such math stuff, feel free to let me know. and I will do it. Bye bye.